Hi my friends, how are you? I hope everybody is fine. My name is Daniel Villarino. Welcome to my YouTube channel. I know that in the previous video I told you that in this video I was going to do a couple of cap centers for finishing the spheres that we were turning in previous videos when you have the two knobs on each side because you were turning between centers, or one knob on one side because you turn with the chuck and that's the place where you did the cut. But I think there is another project that is going to be based for one of these cap centers and also can be based for several other projects. So I would like to work on that first. Now let's take a step back, and if you think about all lathes, what they had was a spur center on one side, and on the other side they used to have a fixed center. So while the spur center was rotating the piece, on the tailstock you had this point that was exerting pressure and generating friction between that piece of metal and the wood, and what turners did was to lubricate it with wax, oil or some other lubricant. With modern technology the live centers appear, and I have here several. This one, for example, is a very typical one. You have the Morse taper on this side that goes inside the tailstock, and then you have the rotating part on this part. And now this rotating part accompanies the piece of wood that is rotating, and there is almost no friction because inside you have bearings. Now I have this other one, is similar, although all this part is fixed, including the Morse taper, and the part that rotates is just this part here. I also have this one, which is very flexible and I use a lot, and I like it because of that. This conical part in the point, you can get either further inside or further outside, or even remove it completely and you already have like a small cap center there. And then it has this threaded part that you can use with a threaded piece of wood like this one. Put it like this, and then you can turn on this side the curvature and you already have a rotating cap center. This is actually one that I use most of the time. Now what I would like to do today is to work on a rotating live center, and in this particular case it's going to be a rotating cap live center, and for that we are going to use these bearings. I bought a bunch of them. These bearings have an internal diameter of 3/4 of an inch and an outside diameter of 1 inch and 3/8. 10 of them cost me $17, and they will be used in other projects as well. Here you can see their specifications. So it's pretty sturdy. I like this more than the bearings that come for the inline skates because these are bigger and more robust. So I'm going to use one of these. I'm going to put a Morse taper on the inside. That is going to be the piece that is going to go in the tailstock, and on the outside I'm going to create a piece of wood that is going to be on this part, and it will have the cap shape on this part and it will be rotating. So we are going to generate a rotating cap center. That's today's project. I hope you enjoy it. Let's get to work. I have this oak cylinder and I will place it between centers. I take the measure of the length of the Morse taper and I fix it in the caliper. I get the tool rest as close as possible to the cylinder and I support the caliper with the tool rest, and very slowly I get the points closer to the wood to mark the distance. With a pencil, I define better the lines. I fix in the caliper the most taper, smaller diameter measure. Being careful that the width of the parting tool is towards the outside of the mark, I begin the cut. I reduce the diameter until I can pass the caliper. I fix in the caliper the most taper widest diameter. Once again, I make sure the width of the parting tool is towards the outside of the mark and I begin the cut. I mark reference lines on each side. Every so often I check the step on each side to see if the cut goes even. With something straight, I verified the profile has no hills or valleys. Once again, I verify that the profile is straight. I mark where I will do the final cut. I measure and fix in the caliper the internal bearing diameter. The bearing has two ledges. One, indicated by the yellow arrows, looks like a flange on the external part, and the other, shown by the blue arrows, looks like a protrusion of the internal part. I will make the internal protrusion to stop against a step that I will form. After forming the step and the cylinder that will go inside the bearing, I am going to cut the piece on the side of the thinner part of the Morse tape. I remove the step center, and in this place I put in the headstock the piece that I just profiled. Fits like a glove. I glued the bearing to the wood using thick CA glue. I removed the piece from the headstock. The marks in the taper are indication of a good fit, and I verify the bearing rotates freely. For the cap, I'm going to use this walnut cutoff that I had. I will screw it to a small faceplate. I should have used a larger piece of wood. Later, you will see that for being stingy, I got into some trouble. I use a Forstner bit of the required diameter. I could also have done the perforation using the parting tool. Gluing the bearing at this point was a mistake. I should have done a jump chuck with a wood cylinder from some scrap, then remove the walnut piece from the faceplate, jam it in the wood cylinder and turn the cap, and only then should I have glued the bearing. I got excited and I jumped the gun, and later I had to do some juggling to get out of the trouble. At the end it worked out, but cost me some time and effort. To put the tailstock to stabilize the piece was also a mistake. I put too much pressure, and when I tried to remove it, I damaged partially the walnut piece. I put a glue block that has a hole wide and deep enough to house the Morse taper. I measure the bearing flange. I will make a small mortise so the flange will fit snugly. I keep cutting and trying until the small bearing flange fits snugly. Now fits and does not have any play, so I know that it is well centered. And I glue it to the glue block with a bit of hot glue that after I let cool down very well. With light cuts I begin to shape the cap. At the end, I smooth the surface and give the final touches with a circular carbide cutter. I sand everything well with 80, 120, 220 and 320 grits, but I do not finish the inside since there I will glue a piece of synthetic leather. Between the parting tool and a knife I remove the glue and free the piece. I put the cap live center with bearing in the tailstock and I give it a first test run, and also I take advantage of this placement to remove the rest of the glue and finish the exterior. I had this piece from another project and it has a shape that is pretty spherical, and I decided to place it between the center we just did and the glue block that will work in this case as a cap center since it has a central hole, and this way I can try the center and see how it works. When I speed up the lathe it begins to vibrate a little because the piece is severely out of balance, but it works well. In a piece of wood I made a rounded shape so that it will pressure against the bottom of the cap a piece of synthetic leather. Finally, with a knife I remove all the leather excess and I let the glue to dry for several hours. Okay, my friends, I finished making the live center with the cap format over here, and I put there a piece of leather attached so that it will not mark the wood when it is rotating. It has a Morse taper, number 2 in my case, because those are the measures for my lathe, and it has the bearing there that allows for the rotation of the mobile part here. And the same way that you do this, you can do several other things. You could make a cone, you can make a jam chuck, you can thread something and put there a chuck. So the same system with the bearing can work for many other things. Now I had to do the one on the headstock, and for that there are several different methods, and we will see that in the next video. You can do it with a Morse taper as well, like this one, or you can do something similar to this, which is a threaded piece of wood that you just put on the screw of the axis of the lathe, and then make the curvature here to match the sphere. And actually in this video you could see that I put there sort of like a sphere between these two, and it worked pretty well because this already works like a cap center there. So that will be material for the next video. For this video this is all. I hope you enjoyed. If that's the case, please don't forget to mark the like button below, make comments, and if you haven't subscribed yet to my channel, please do so. And it will be until the next one. Cheers!